Decide whether the integral converges or diverges using the comparison test. Integral 4 to infinity sine of x over x squared plus e to the minus x dx. So first, let's think about this intuitively. When x goes to infinity, this e to the minus x goes to 0 very quickly. So my intuition is that that part isn't going to be the thing that makes or breaks this integral. Sine of x, I know, bounces between -1 and 1. So I feel like I'm not really going to be using the sine of x. I think it's the x squared on the bottom that is the most important piece of this improper integral. And if I think about ignoring everything else except for that x squared, so I guess I need a 1 there as a placeholder. This is the integral I'm thinking about comparing to. And this particular integral converges. We know this is one of our useful integrals for comparison. In this case, the power 2 is bigger than 1, and so therefore this integral converges. So what I'm hoping is that this whole integral here turns out to be less than or equal to this one, because this one is convergent. It's finite. So less than or equal to is the direction that we were after. I don't know how much control we have over this thing, but less than or equal to is what we're hoping for. So as I said, we know that sine of x is less than or equal to 1. It's also bigger than or equal to -1, but that less than or equal to is the direction of the inequality that we're interested in. So I'm quite happy right now to leave it as a sine of x there. And then let's start writing. So we go sine of x over x squared plus e to the negative x. That's the integral we're trying to build, or the integrand we're trying to build, is now less than or equal to 1 over, and then copy the bottom. And now what I'd really like to do is ignore this e to the negative x. Well, e to anything is always a positive number. So that means that if I just compare the denominator, just the denominators, I know that this thing on the left is more than the thing on the right, again, because e to the negative x is always positive. So the left-hand thing is bigger just on the bottom, so therefore when I do 1 over each of them, the inequality flips over and we get less than or equal to in between. So that's what we put right there. And voila, this is exactly what we wanted. There's our original integrand, and it is less than or equal to that integrand. And so now we just need to complete this by talking about the integral of 1 over x squared. Integral 1 over x squared dx from forward to infinity converges by useful integrals for comparison. And then we'll just put here in parentheses, I forget what letter we use. Is it a p? P is equal to 2, which is bigger than 1. And so the integral that we want is smaller than a convergent integral. So that means that the integral that we want also converges. And that's by the comparison test.